Look around you. Our entire lives are intertwined with energy. From ancient fires and winds to modern nuclear reactors and solar panels, humanity has always sought to improve its existence by harnessing new technologies and transforming the surrounding world. Progress has always fueled the search for and creation of new energy sources, but everything we've accomplished thus far pales in comparison to the amount of energy our sun produces every second. But what if we told you there's a concept that could enable humanity to harness all of the sun's energy? Hello, dear friends. In today's video, we'll tell you about the Dyson sphere and how it can be built. But before we begin, we'd like to ask you to subscribe to our channel and hit the notification bell so you don't miss out on our new and intriguing videos about the mysteries of the universe and our planet. First, let's understand what a Dyson sphere is. It's a massive station that captures all the emitted light from a star and directs it towards energy production. This concept was named after its creator, Freeman Dyson, who conceived it in 1959. The idea itself wasn't entirely new, as Dyson himself acknowledged being inspired by the science fiction novel The Star Maker, written by Olaf Stapledon in 1937. Needless to say, even in the Middle Ages in the 15th century, Italian thinker Marsilio Ficino, foreseeing humanity's future possibilities, confidently wrote,
"Man measures the earth and the heavens. Neither the heavens seem too high for him, nor the center of the earth too deep. And since man has understood the arrangement of celestial bodies, who would deny that the genius of man is almost equal to that of the creator of celestial bodies, and that he could somehow create these celestial bodies if he had the tools and the celestial material?"
It's worth noting that while the Dyson sphere is not an analog of a celestial body like a star or a planet, it in some sense utilizes the former and replaces the latter. Under the Dyson sphere concept, any structure can be understood, not just a sphere. The key is for this structure to be massive and intercept a significant portion of the sun's radiation, not fractions of a percent like existing planets in our system. Now, after a brief lesson in history and philosophy, let's discuss the main problems associated with building a Dyson sphere, which can be summarized in just 4 points. How can humanity create a sphere with a radius ranging from 50 to 250 million kilometers? What tools can be used to create such a sphere without harming oneself or the entire system? What material determines the possibility of creating such a sphere with its presence, quantity and quality, and location, which needs to be determined in advance before construction to avoid later finding that the presence of the sphere in that location only complicates civilization's life or is simply dangerous for the entire stellar system? Let's start with the last problem, the location of the sphere, as it's the most crucial decision that significantly impacts subsequent ones, and the answer to the question of where to place the sphere directly depends on its purpose. Option A. If we need a Dyson sphere simply to maximize energy from the sun, without considering the preservation of planet illumination, especially Earth's, it would be logical to position the sphere as close to the sun as possible. As close to the star, a rotating and not necessarily solid, sturdy and coolable shell with energy collectors and emitters is created to obtain maximum energy with minimal construction volume. How close to the sun can such a sphere be built? If we consider heating the shell by the sun to 1000 kelvins without special cooling, the radius would be around 23 million kilometers, which lies within Mercury's orbit. All received light energy is converted into another form, such as electrical, and then transmitted somewhere via radio waves or applied on-site. However, during the creation of such a sphere, two main problems arise. The first one is the cooling problem. The sphere must not melt or deform from the sun's energy, and gravitational stability problem, meaning the sphere must not fall onto the sun or break from its gravity. The strength of any modern materials is the main problem for our level of development. Nevertheless, such a sphere is justified for civilizations of a high level, especially if it's a means of colonizing not their own star, but a foreign one. A construction of this kind is particularly relevant for white dwarfs. They shine without flashes and coronal mass ejections. They are small in size and luminosity, allowing the creation of a sphere with a radius tens of times smaller than around an active sun. Option B. If we need a sphere as a habitat for humans, requiring necessary infrastructure, atmosphere, soil, plants, and animals, then the sphere must be sturdy and located where the sunlight intensity is approximately the same as on Earth's surface. That is, the sphere should be positioned at the distance of Earth's orbit or even farther. 3 new problems arise in addition to the previous ones. The sphere must be stable to avoid disturbing the orbits of other planets. This means it should be positioned approximately 40 million kilometers from Earth. The sphere must be very sturdy and thick enough, which concerns the composition and quality of materials in the solar system. And what about material? The solar system is not infinite, and such a sphere may require an excessively large amount of material. Moreover, simple deductions from Gauss's law and Newton's shell theorem reveal that being inside the shell would be dangerous for humans. They would be attracted towards the sun, not the shell, regardless of its thickness. Though the falling issue can be addressed by spinning the sphere to achieve a normal orbital speed for its radius, the atmosphere won't be retained well. As a result, all sunlight will be reflected from the shell, and the trapped solar wind inside the sphere with high intensity won't have anywhere to escape. In simpler terms, this variant of the Dyson sphere is only feasible for idealistic dreams of civilization's power. It's dangerously unstable, and the materials in our system simply wouldn't suffice. Option C. If we need a sphere with a thin, easily repairable surface intercepting sunlight, not necessarily solid, but with maximum surface area and minimal energy flow to avoid overheating concerns, then the sphere should be positioned even farther from the start. The problems remain the same, with the addition of one more: collisions with asteroids, comets, and the like. This problem is more severe than for the previously discussed options because due to the distant orbit, the surface of such a sphere crosses paths with many more small celestial bodies per unit of time. In reality, if the purpose is to utilize at least some portion of solar energy, such a sphere is permissible even closer to Earth's orbit. Moreover, these assumptions open up wide possibilities for various forms and types of constructions. One could opt for those accessible with current technologies without aiming for the unrealistic. For instance, moving away from a singular sphere to individual components comprising what's called a Dyson swarm. This means a large number of small-sized objects that capture and process energy, then transmit it to consumers. In conclusion, of all the possible variants of the Dyson sphere, the Dyson swarm appears to be the most reasonable because it's more realistic than other types, and it's quite feasible to gather sufficient resources for its creation. Let's assume that humanity is poised to harness solar energy and has decided to create a sphere or a Dyson swarm. How would this unfold? Where would a technological civilization begin the assembly of any Dyson sphere? By deploying individual sphere elements into orbit. Only elements of the Dyson sphere moving along stable circular orbits with the required radius can be assembled together without rigid connections with gaps, gradually step-by-step forming, not a sphere, but only a ring, as the higher or lower an element is above or below the ring's plane. The more challenging it is to place it on a stable orbit that doesn't intersect the already created ring and isn't significantly distant from it in terms of radius. Most likely, the assembly would commence with the construction of a part of the Dyson ring in the ecliptic plane. After all, outside the ecliptic plane, there are fewer asteroids and other material for constructing the ring. Additionally, it's easier to deliver this material to the required radius in this plane and impart the necessary orbital speed to it, or to the already constructed ring element. Following the creation of a flexible consisting of unconnected or weakly connected elements ring of the specified radius, with the accumulation of experience and technology enhancement of civilization, other rings can be constructed, this time perpendicular to the ecliptic plane and at an angle to it. However, these rings must have a noticeably increased or decreased radius to avoid interfering with the initial ring. Nonetheless, the sequence of actions will remain essentially the same. If a Dyson sphere is ever successfully constructed, it would signify a real breakthrough in the development of human civilization. Perhaps someone out there in the distant cosmos has already achieved this, but that's a whole different story. Thank you very much for watching. If you enjoyed this video, don't forget to like it and subscribe to the channel to stay updated on new and intriguing videos about the mysteries of the cosmos. Write in the comments what you would like to learn about next time. Thank you, and see you next time